Factoring special cases. These are like when we had those old shortcuts when we were multiplying, and it really wasn't even that short. Simplify each expression. 3x raised to the second power. 3x squared really means 3x times 3x, which would be 9x squared. You just square each part. Here, we're squaring 5, we're squaring the y. 5 squared is 25, y squared. Here, 15 squared, I believe, is 225. And when you do h squared raised to the second, remember the old property, you multiply the exponents. So that would be h to the fourth. Here we got to square everything. 2 squared is 4. A squared, b to the fourth. All right, now here's what we had back in the day. It's the same thing except one's a plus, one's a minus. It's called difference of squares, and there was a shortcut for that, and it actually is shorter. But you would get it if you FOILed it out anyway. You square the first term, boop, c squared. You always put minus, and you square the second term. 6 squared is 36. Because you would have a positive 6c and a negative 6c that would cancel out if you FOILed it. Now here, back in the day, it was written as p minus 11 squared, and then we turned it into p minus 11 times p minus 11. Was there a shortcut? Sure. But it really wasn't worth the time or effort to do it the shortcut way. But the shortcut was you square the first term, p squared. At the end, you square the last term. 11 squared is 121. The middle term is the tough one. You multiply them together, and then you multiply by 2, because there would be 2 of those negative 11p's. So p times negative 11 is negative 11p, times 2 is negative 22p. Great. What a shortcut. My goodness, we've saved hours. Again, here, it would have been written as 4d plus 7 squared. Then we turned it into this. But the shortcut is you square the first term. 4d times 4d is 16d squared. You square the last term, positive 49. The middle terms where we multiply them together and multiply by 2. If we multiply those together, that's 28d times 2 is 56d. Fantastic. So we're going to be factoring today, and it's going to give you something like this. You're going to have to turn it into this. So you're going to have to recognize these, and you could do it the long way, but the whole point of seeing it this way is like you could factor certain things very quickly if you recognize, hey, that's a difference of squares. Then you don't have to do like the first times the last, find the ones that add up to the middle. Like, it's nice. So you want to see, like, can I square root the first term? Can I square root the last term? Then there's a pretty good chance it's one of these perfect square trinomials or difference of squares. So let's look at what we've got here. If you look at this one, can you square root x squared? Yeah. Can you square root 16? You bet your face you can. But let's pretend like you didn't even know that. You're looking at factors of 16. 1 times 16, 2 times 8, or 4 and 4. Which set gives you the middle number? 8. The 4 and 4. Now, these would have to both be minus, because negative times negative is positive, negative plus negative is negative. And then you would just rewrite x minus 4 times x minus 4 as x minus 4 squared. Again, thanks, it didn't save us that much time on this one. And that's okay. In the future, it'll save us some time. So this one, look at each one of them has a first and last term that you can square root. So we're going to do that. Square root of x squared is x. Square root of 16 is 4. Now, what symbol goes in the middle? Because all of them are going to end up with plus back there, because it's either a positive times positive or a negative times negative. So then you have to look at the first symbol. It was plus 8, so boom, plus 4. Ugh. Look at this one. Square root of n squared is n. Square root of 64 is 8. The first symbol's plus. That means a plus is going in the middle. The only difference on C is that first sign is negative, so that would just make it n minus 8 squared. Come on! Here we go. The area of the square shown at the right is 9g squared plus 12g plus 4 centimeters squared. Find an expression for the length of aside. Now, squares, length and width are the same. It doesn't matter. They're basically giving us a fancy way of saying, factor this. If you look at the first term, you look at the last term, can I square root those? Yes. The square root of 9g squared is 3g. The square root of 4 is 2. The symbol in the middle comes from the first symbol. So it would be plus 3g plus 2 squared. It's done. You have other ways that you can do this. You can multiply. 9 times 4 is 36. And then you list the factors of 36. 1 and 36, 2 and 18, 3 and 12, 4 and 9, 6 and 6. The set that adds up to 12 would be 6 and 6. So you're like, great, that's g plus 6 times g plus 6. We always try to divide by the number in front, which is 9 in this case. 6 over 9 would simplify to 2/3. And then the 3's would come to the front, and it would become 3g plus 2 times 3g plus 2, which we would then rewrite as 3g plus 2 squared. Same thing we got with the shortcut, but look how much more work we did. So if you can recognize a perfect square like that, it just saves you work. So also, you do want to check that middle term though. This 12g. It's what you would get if you multiply these two together and then multiply by 2. So if I did 3g times 2, it's 6g. And if I multiply that by 2, it gives me 12g. Because if I was to FOIL this out, we would have a 6g there, and we would have a 6g there. There's 2 of them. That's why we always multiply by 2. Here we go. Same thing except it's minus. These are both the same problem, except C has a minus, B has a plus. So we'll just do C. Now, we'll square root the first and last. Square root of 4t squared is 2t. Square root of 81 is 9. The symbol in the middle comes from the first symbol. Woo-hoo! That's it, man. That is it. All right, now here's the fun ones. When there are only 2 terms, that was created from a difference of squares. So when we factor these, we're going to square root them both, but we're going to put one with a plus and one with a minus. If I do the square root of x squared, what times itself gives you x squared? X. How about 64? That's 8 times 8. So this would be x plus 8 times x minus 8. Done. If you FOIL that out, here you'd have x squared minus 8x plus 8x minus 64. And that negative 8x plus 8x cancels out. So we just have x squared minus 64. Oh my gosh. What? When you have 2 things you could square root with a minus in the middle, square root them, put one with a plus, one with a minus. Square root of x squared is x. Square root of 36 is 6. It's almost too fun. Almost. Can I square root m squared? Yeah, it's m. Can I square root 100? Yeah, it's 10. So m plus 10 times m minus 10. Can I square root both of these? Yup. Square root of p squared is p. Square root of 49, 7. Next. Oh my gosh, bigger numbers. We should always look for a greatest common factor, which, if you look at all of these, none of them have a greatest common factor except for 1. So, can we square root 4x squared? Sure. Square root of 4x squared is 2x. Can we square root 121? Yeah. That's 11 times 11. So we'll have 2x plus 11 times 2x minus 11. Nice. I could square root 9v squared. That's 3v. I could square root 4. That's 2. 3v plus 2 times 3v minus 2. It's too much fun, right? Oh. On B, square root of 25x squared. Oh my gosh, that's 5x. Square root of 64 is 8. 5x plus 8 times 5x minus 8. These ones, oh, too easy. 2 dubs plus 7 and 2 dubs minus 7. I know, you're sitting there going, Mr. Plant, please, we're not babies. We're ready for the next one. Okay, all right, man. Here it is. Oh! Square root of 10x squared is, oh, can't square root it. All right, but is there anything maybe they have in common? Because I should always look for a greatest common factor. Oh, 10. 10. Always look for a greatest common factor first. So if we factor out a 10, we're left with x squared minus 4. OMG, I can square root both of those now. The square root of x squared is x. The square root of 4 is 2. X plus 2 times x minus 2. And again, it's too much fun. Look at A. I can't square root either of those, but I know they're both even, so I know I can factor out at least 2. 2 times 4y squared is 8y squared, and 2 times 25 is 50. Now I could square root both of those. Square root of 4y squared is 2y. Square root of 25 is 5. 2y plus 5 times 2y minus 5. All right, on B. Oh my gosh, those are both divisible by 3. Factor out of 3, we're left with c squared minus 25, which those are both perfect squares. So that would be c plus 5 times c minus 5. Say it ain't so, Mr. Plant. The last one. Those are both divisible by 7. 4k squared minus 1. And then I can square root both of those. 2k plus 1 times 2k minus 1. I think that's it for the notes. That's it, man.